Today we're going to start a new lesson. We're going to talk about the antiderivative. To talk about the antiderivative, let's just backtrack to some basic derivatives. So let's look at function f of x. So if I gave you f of x is equal to x squared and I asked you for the derivative, you would tell me that the derivative is equal to, drop the 2, and then subtract 1 from the exponent. So 2x. All right, let's go with another one. If I gave you another basic function, so we'll say g of x is equal to x squared plus 6. G prime of x is equal to derivative of the first piece, so 2x, and then the derivative of the constant, which is plus 0. All right, let's go for one more. X squared plus pi. All right, so to find the derivative of h, take the derivative of x squared, so I get 2x to the first. And then pi is a constant, so plus 0. So notice all three of these functions, although they were different functions, gave us the same derivative, which was 2x, because we know that the derivative of a constant is always 0. So what we're going to do now is we're going to find something called the antiderivative. What happens with the antiderivative is you're going to start with the derivative, and you're going to work backwards to find the antiderivative. Okay, so let's first talk about notation. When they ask you for the antiderivative, we use this really funky looking symbol. We're going to find the antiderivative of f of x with respect to x. Remember, that means with respect to x. So this is read the antiderivative of f with respect to x. So if I want to take the antiderivative of 2x, I would use this little symbol and I would write 2x. And now I'm going to reverse the process completely. When I took the derivative, I dropped the exponent, I subtracted 1 from the exponent. I'm now going to reverse that. So I'm going to find the exponent, which is right here. I'm going to add 1 to the exponent. And then instead of multiplying, I'm going to divide. So add 1 to the exponent, which gets me 2 as an exponent. And then divide the coefficient by 2. So the antiderivative of 2x to the first is now 2x to the second over 2. Now remember, when you take the derivative of a constant, it disappears, so I have to represent that something was there, or something could have been there at some point. So 2x squared over 2 is really 1x squared, and then plus something, I don't know what that something is, so I'm just going to use a c representing that there could have been a constant there. So the antiderivative of 2x to the first is x squared plus c. So that now will cover all of my possible functions that would give me a derivative of 2x. This little symbol here has a special name. This is called the indefinite integral. It's the symbol for when they want you to do or take the antiderivative. Okay, so let's look at a couple different facts and then we'll find the antiderivative for a few basic functions. Okay, so first thing we should know is that when we take the derivative of a constant, we get 0. We know this already. when we take the antiderivative of 0, we're going to get a constant. That's why we had to put c at the end of the other integral. When we take the derivative with respect to x of a constant times x, a number times x, we get just the number in front. So that means that when we take the antiderivative of a constant, a number, looks like just a number, with respect to x, we get the constant x plus c. So it gets a little tricky because you have to reverse the way you've been thinking for a while. We've been talking about derivatives for so long, and now we have to do it backwards, and after we talk about the antiderivative. All right, so let's try a couple practice problems. All right, so the question would be, find the antiderivative of 3x. Okay, so I'm going to use the notation. I'm finding the indefinite integral of 3x with respect to x. Okay, so my exponent is 1. So I'm going to add 1 to my exponent. I'm going to make it 2. I'm going to divide by the exponent. And then remember, there could have been a constant there. I don't know what it is, so I'm just going to put plus c. So my indefinite integral for 3x to the first is 3 over 2x squared plus c. Now, if you have multiple pieces to your derivative, when you're finding your antiderivative, you would just take it piece by piece. So let's pretend we have, find the antiderivative. Actually, let's do one more easy one before we do a harder one. Of 4x to the third. All right, so I'm going to write indefinite integral of 4x to the third with respect to x. Okay, so I'm going to add 1 to the exponent. So I get 4. And then I divide by 4. And then again, there could have been a constant there, because remember, when we take the derivative of a constant, it's 0, so I have to put plus c. So my antiderivative, I can clean this up a little bit. 4 over 4 is 1. So the antiderivative of 4x to the third is x to the fourth plus c. All right, let's do one that has a couple pieces to it. Okay, let's find the antiderivative of x plus 2. All right, so I'm finding the indefinite integral of x plus 2 with respect to x. So when I have a binomial, I'm going to take the antiderivative separately. So I'm going to perform the antiderivative on x and then on 2. All right, so the antiderivative of x with respect to x. So I'm going to add 1 to the exponent and then divide by it. And remember, there's plus a constant. I don't know what it is. But you know what? There's going to be 2 constants here, so I'm just going to name this one constant 1. All right, now I'm going to take the antiderivative of 2 with respect to x. So remember from before, we said if we're taking the antiderivative of a constant, let's just go back. If we're taking the antiderivative of a constant, we're going to attach the x and then add the constant. So really there's x to the 0 here. So now there's going to be 2x to the first plus another constant. I don't know what it is. I just know it's a constant. But I do know that these are just both numbers. So it doesn't really matter what those are called. All right, so now when I write the entire antiderivative of x plus 2 with respect to x, I have x squared over 2 plus 2x plus these numbers. I don't know what those numbers are, but I just know they're a constant. So I can add those numbers and come up with a new constant. So that is the antiderivative of x plus 2. All right, let's try one more, and then you'll have a few to try by yourself. So that was 3, this is 4. Okay, so we'll find the antiderivative of x to the third minus 4x plus 1. All right, so they can answer the question this way, or they can just right off the bat give you the integral symbol and ask you to perform the integral here. So they'll either give it to you in words, say find the antiderivative of this polynomial, or they'll give you the integral and they'll ask you to find the integral. All right, so let's find the integral here. So I'm going to find the integral of the first piece. So the integral of x to the third, the antiderivative, add 1 to the exponent, divide by the exponent, add a constant. Second piece. Add 1 to the exponent, divide by the exponent, add a constant. Third piece. Add 1 to the exponent, so now I have an x, add a constant. So my antiderivative is x to the 4th over 4 minus 4x squared over 2 plus x, add all those up, plus the constant.